You know, our whole modern world, it runs on energy. But what if I told you that the places with all the energy and the places that need all the energy are on completely opposite sides of the planet? Well, that's what we're calling the Great Energy Mismatch, and trust me, it shapes just about everything. Let's dig in.
So, here's the big question at the heart of it all, and it's a simple one, but with absolutely massive consequences. Why is the energy that powers our lives found in one corner of the globe, but used in a totally different one? This geographic puzzle, it's the key to understanding, well, our entire global energy system. Think about it like this. On one side of the scale, you have the absolute epicenters of supply, right? Heavily concentrated in places like the Middle East. And then, on the other side, you have the biggest consumers. We're talking economic powerhouses like China, Europe, and Japan. They're separated by thousands and thousands of miles. This wasn't planned. So how on earth did we end up with this massive global divide?
To really get the supply side of this, we've got to go way back, millions of years back. See, this isn't a story about modern countries or economics. Nope, this is about ancient geology, basically a lottery that decided long before we were here which parts of the world would be rich in energy and which wouldn't. The energy we've depended on for over a century, fossil fuels, it isn't something we just invented. It's the result of a very specific and very ancient recipe. You needed the right kind of organic stuff, buried under the perfect amount of heat and pressure for millions and millions of years. And those perfect conditions, they only happened in a few, let's call them lucky spots on the planet. And the grand prize winner of that ancient geological lottery? Without a doubt, it was the Middle East. It's almost hard to wrap your head around just how concentrated the world's oil is in this one single region. We are talking about nearly half of all the oil we know exists. 48%. Let that sink in for a second. Almost half of the world's known oil reserves are sitting in one region. That's the crucial thing to remember here. The location of our main energy source has nothing to do with modern countries or economies. It's all about ancient geology.
Okay, so that's the supply side. Ancient, fixed, and pretty much set in stone by geology. But demand? Demand is a whole different story. It's not about ancient history. It's about our history, written in just the last couple of hundred years.
Right. So unlike supply, energy demand isn't driven by rocks and fossils. It's driven by us, by people. And the equation's actually pretty straightforward. The more people you have, the bigger their economies get, and the more technology they use, well, the more energy they're going to need.
Japan is the perfect example of this disconnect. It's a technological and industrial giant with a huge appetite for energy, but it pretty much lost that geological lottery we were just talking about. And the result? A truly staggering 90% of its energy has to be imported. Its entire modern economy is completely dependent on the rest of the world for power.
And the European Union finds itself in a similar boat, even if it's a little less extreme. I mean, despite having some of its own resources, the EU's collective hunger for energy just totally outstrips what it can produce at home. It has to rely on imports for over half of its energy needs, which means it's also deeply tied into that global supply chain.
But the story isn't just about pure importers and pure exporters. It actually gets way more complicated. Some countries are absolute giants on both sides of the equation. They produce a ton and they use a ton, and that creates a whole new set of power dynamics.
The US and China are the two best examples of these giants. In the United States, you had the shale revolution, which turned it into a top global energy producer. But its massive economy means it's also a top consumer. And China's in a similar spot. It's the world's #1 coal producer, but its incredible growth means it now burns through more than half of all the coal used on the entire planet.
So, even for these absolute behemoths, the mismatch is very real. It's kind of like having a huge garden in your backyard, but still needing to go to the grocery store every single day. When your economy's appetite is as big as it is in the US or China, demand can easily outrun even your massive domestic supply. And that means they still rely on imports to keep the lights on.
So we have this fundamental imbalance that's just baked into our planet. But why does it matter? What are the real-world stakes? Well, because this geographic accident has profound consequences for pretty much every country in the world. This mismatch creates two very different realities. For importers like Japan and Europe, it means they have to live with this constant vulnerability, Their economic stability is tied to things happening thousands of miles away. But for exporters, like in the Middle East, it's a source of incredible wealth, sure, but it can also be a curse, creating economies that are dangerously dependent on just one resource. Ultimately, when you boil it all down, it comes back to this one simple fact. The global distribution of fossil fuel supply does not match the regions where demand is highest. This isn't just some quirky little fact for a trivia night. It is the fundamental imbalance that drives our entire global energy system. It shapes alliances, it fuels conflicts, and it defines the relationships between nations. For over a century, our world has been shaped by the winners and losers of a lottery drawn millions of years ago. But now, a new energy map is being drawn, one that's based on sun, wind, and new technologies. And that leads us to maybe the biggest question of our time. As this new energy lottery begins, who are the winners and losers going to be this time around?